Kia ora Year 11 and Year 12. This is the first algebra revision video that I've done for a while, and it's going to look at some harder examples of the difference of two squares pattern. So if you're in my class, you know that I'm pretty obsessed with the difference of two squares. It comes up all the time in algebra problems, and it really helps us to solve equations. So my focus in this video is not going to be much on solving equations. It's just going to be on spotting the pattern so that we can go a little bit faster. But first I want to look at what I mean by saying how it helps us to solve equations. Well, here we've got our classic difference of two squares. Now, suppose that I write this into an equation. So I have x squared minus 9 equals 0. Well, if I look at it as the difference of two squares, I'm writing it as two factors. And one of those factors is going to be x plus 3, and one's going to be x minus 3. Right? So here we get an x squared. Next, we get a plus 3x, then we get a minus 3x, and lastly, we get a minus 9 equals 0. Okay, so we started out with x squared minus 9 equals 0, and we ended up with a product. Products are really good for solving equations. So in this case, you could have looked at this one and gone, oh, well, x is 3 or negative 3, right? So you could have solved that equation by saying x squared is 9, x is equal to plus or minus root 9. But when we get to some of the harder pattern types, we can't do that as easily. So completing the square is a really good technique to be able to spot. So what I'd like to do in this video is get gradually more difficult. So I'm going to put up several screens now of the problems that we're going to work through. So what I'd like you to do is to pause the video as I play through those screens and copy down the examples. Leave a gap between each one, and then go ahead and try and do as many as you can before you watch the video. And then come back and I'm going to go through each one. For some of you, you'll see that the pattern is the same everywhere, but for others watching this, you're probably going to get stuck as they get a little bit harder. So here's the first screen, and there are 5 screens altogether. So pause and write them down. Okay, here's the next screen, just handwritten this time, getting a little bit harder. Pause the video and write down the equations. Screen 3, pause the video and write down the equations. Here's, oh, I've got too many on one here. So this is the start of screen 4. And there's the next bit. And here's the very last screen that I've done. Okay, so the longest I can go with this is 15 minutes. I'll give anyone who watches till the end a pineapple lump, but you have to really watch to the end, and you'll have to come and show me how you solve those last 2 equations. Right, so going back to the first ones, what I want us to do here is to get used to the basic pattern type. I've got a square number here, I've got a takeaway here, and I've got another square number here. So my brain needs to be wired that I'm always looking out for that pattern. And then once it is, we're going to factorize as follows. It's going to be x times x, because that will give me x squared, minus 4 here, and plus 4 here, right? And I've already gone through how that expands back, but just one more time. We get x squared minus 4x plus 4x, so they disappear, and then take away 16. Okay, on to the next one. So the only difference here is that I've got 4a squared. So I need to think about what's the square root of 4a squared. And it's 2a. So it's going to be 2a minus 7 plus 7. Next one. What's the square root of a to the power of 4? Well, when we have exponents and the base is the same, remember that we add the powers. So a squared times a squared is equal to a to the power of 4. So this one's going to be a squared minus 3 times a squared plus 3. Right, just checking that back, we get a to the power of 4 here, minus 3a squared here, plus 3a squared here, minus 9. Now let's look at the next one. This is a to the power of 6. So when I've got an even numbered power, I can easily do a square root on this. This is going to be a cubed times a cubed is equal to a to the power of 6. So you're quickly going to get into a pattern where you have this number here where you're doing this. Right, so it's going to be a cubed minus 4 times a cubed plus 4. Right, just expanding that out, look at that. The a cubed times the a cubed gives me the a to the power of 6, and so on. Okay, so these ones here are very similar, but now we've got a coefficient with the x squared. Right, we're doing exactly the same thing. We're looking for the square root of this here. So 7x here times 7x here minus 1 plus 1. Now, the tricky thing here to notice is that I've got a common factor in my numbers. So the coefficient here is 54 and the number here is 6. Let's take out that common factor of 6 and see what we've got left. Now, since I've put it in a video on completing the square, on difference of two squares, it's probably a difference of two squares. Right, so I've got 6 times this, 3x times 3x minus 1 plus 1. So just notice with these ones, with the 49x squared, I've got 7x times 7x. Here I've got 9x squared, so I've got 3x here and 3x here. Just one more thing that you can't do here. You can't say that this is equal to 3x minus 1 times 3x plus 1. That is not right, okay? So we don't ever want to write that. It's 6 times all of that. If we're solving an equation, then it's a different story. We can divide both sides by 6. But if it's just an expression, then we can't do that. Okay, so we're going to pretend we didn't ever see that. Right, we're going to follow the same pattern now. We're just looking at each term and figuring out the square root. So the square root of 16x to the power of 6 will be 4 times x cubed minus 7y, and then 4x cubed plus 7y. So notice how the examples are gradually looking messier, right? On to the next ones. Now we've got combinations of variables and no coefficients, but it's the same idea. The square root here will be a squared b cubed minus cd, and then a squared b cubed plus cd. Here, the square root is going to be 12, and 12 here, minus 5a plus 5a. In this one, we've got three things, right? We've got a coefficient, an a and a b, and then a c and a d. It doesn't matter, right? As long as we can take a square root here, we're fine. So this is a square number, and this is a square number. The square root here is going to be 10ab cubed minus 7c squared d to the power of 13. Just checking that you're awake. No. Yeah, so we're just halving that 26. And here we've got plus 7c squared d to the power of 13. Right, I think that's all on that screen. Okay, now we're starting to crank it up a little bit. Here, this is one like the ones we've done. U to the power of 14 has a square root of u to the power of 7. So it's u to the power of 7 minus s to the power of 5 plus s to the power of 5. Now I've put in some more fun ones to end up with. Suppose that we've somehow got this out of a problem. We might have it in an algebra problem where we're trying to find an area or something like that. But again, we've got this pattern where we've got a square minus another square. So how can I factorize it? Well, I get x plus 5 times x plus 5 minus, and I'm going to leave some brackets in here, x minus 3, and here I get plus x minus 3. And this time we can clean that up, except I didn't leave much room. So what do we get here? Well, we've got x plus 5 minus x plus 3. Now I've got x plus 5 plus x minus 3. I'm just going to move that next one away. Let's get rid of that. So I've got some space. So cleaning this up gets me quite a lot further, right? Because here I've got 8 times 2x plus 2. So all of that factorised to give me, I can either expand and get 16x plus 16, or I could say 16 times x plus 1. So either of those would be correct, depending on what we needed to do next or what we've been asked for. This is in factorised form. That's in expanded form. So let's look at this one. It's the same pattern. I've got something squared minus something else squared. So it's going to be 4x plus 5 minus 3x minus 7 times 4x plus 5 plus 3x minus 7. Now notice that I've kept this in brackets. That's to avoid silly algebraic mistakes when I've done a whole lot of work with my good maths brain. Right, so we're just going to be careful with how we expand out, especially that negative sign. And we get 4x plus 5 minus 3x plus 7. Sorry for the monotonous background music, guys, if you can hear it. All right, there we go. So what do I have here? Well, I've got x plus 12 times 7x minus 2. So notice that suppose we'd had this. Let's just give ourselves a bit of space. Let's get rid of this. So suppose that we now look at what would happen if we had an equation. Suppose we had to solve that this was equal to 0. Well, that's really pretty hard to do. But what we've done by doing the difference of two squares is that we've moved down to this form here. So that equals 0. So let's change this slightly now. Right, so we've got this thing here equals 0. So this equals 0, and we get down to here. And it's super easy now to solve it. We've got x equals negative 12, or 7x equals 2, x is equal to 2/7. The other way we could have solved that is that we could have expanded all of it out, right? So expand this quadratic minus expand this quadratic. They both work, but if you can see the difference of two squares, it really will help you with harder problems. Let's look at a couple of last ones that I've thrown in here. We've just got some numbers that are fractions. So let's see what we can spot about these fractions. Now that looks horrible. It doesn't look like a square. If you rewrite it, though, as an improper number, this is what you're going to see. This is x to the power of 50 minus 2 4s are 8, plus 1 is 9, minus 9 over 4. So that equals x to the 25 minus 3 over 2 times x to the 25 plus 3 over 2. This next one is similar. It's x to the power of 8 minus 25 over 16. So you can spot straight away now that this is a square. We get x to the power of 4 minus 5/4 times x to the power of 4 plus 5/4. All right, if you are still watching after 13 minutes of difference of two squares, congratulations. Come and claim your pineapple lump, probably bought by Mr. Hurring and not me. Let me know if this was helpful or if you've got any questions. I know Education Perfect does this really well, but I don't think it does many of these more complicated types. And they do come up in harder questions in the Level 2 algebra exam. Thanks for watching.